Hello everyone, this is the visual abstract of the work called Fatigue Behavior of Metallic Components Obtained by Topology Optimization for Additive Manufacturing. Here is a table of the contents. This is a brief introduction. The present work is a conceptual study and its main goal is to demonstrate the building orientation effect on residual stresses and on the fatigue performance of an optimized component. Topology optimization and additive manufacturing, they share strong synergies. Residual stresses play a key role in fatigue behavior of a component, and these residual stresses are intrinsic of laser powder bed fusion process, so they cannot be eliminated. However, they can be reduced, and choosing things like the best building orientation may improve the fatigue performance. A quick review about the optimization analysis performed here. The way was to minimize the compliance matrix. Also, a volume constraint was imposed. And in order to avoid elements with intermediate density, a solid isotrope material with penalization was applied. This is a view of the geometry along several increments. Residual stresses in metallic additive manufacturing. The residual stresses during additive manufacturing were studied here for 3 building orientation, and the 6 most critical points for each geometry were studied. After that, the residual stresses affecting fatigue. Since we have here a multi-axial nature of the stress field, an equivalent stress method was used, the sinus method. And since the load ratio was -1, all the mean stress present here were only due to the residual stresses. The residual stresses, they can be detrimental for the fatigue performance, or they can help if they are, for example, compressive. This is the cyclic load contribution, and this is the residual stresses contribution. Conclusion. Regarding topological optimization, the applied methodology showed to be capable of obtaining an efficient geometry. The stiffness to mass ratio was improved nearly 6 times. Also, the building orientation during additive manufacturing proved to have a fundamental role on residual stresses, and choosing the right building orientation will result on a better fatigue performance of a component. And finally, for building orientation 2, the residual stresses improved the fatigue performance from 1.1 to 5 times 10 power to 5 cycles. Thank you.